most of what we do is going to involve factoring, which is why I like this part of the chapter so much, because I love to factor. So it says the simplified form of a rational expression. So when something is simplified, what does that usually mean if something's simplified in math? Julie? Yeah, it cannot be broken down any further. So you can't pull it apart any more than what you currently have it. When we're talking about rational expressions, that means our numerator and the denominator have no common factors. So when we say something is in simplified form, yes, it can't be broken down any further. But when we're talking about rational expressions, since a rational expression is a fraction, our numerator and denominator don't have anything in common. So we've broken it down as far as it can go because the top doesn't have anything in common with the bottom. So it says, let A, B, and C be non-real or non-zero real numbers. So it can't be zero because then I don't have a fraction. Or a variable expression. It says then the following property applies. If I am multiplying A times C and B times C, and it must be multiplication, the part that they have in common, which is the C, can go away, can be simplified because I have that same part on the top and the same part on the bottom. So they cancel out, and we're just left with A divided by B. So therefore, my top doesn't have a common factor with the denominator. But when we say they have no common factors, the problem has to be in factored form in order for us to simplify. So I have a couple of, like a little step thing here. We're going to put two steps. The first step is that it must be multiplication. And the only way we can get something into multiplication is to factor. So when something is factored, factors like are multiplication. The factors of 15 are 3 times 5. The word factor means change something to a multiplication problem. What two things multiply together to give me my original problem? So the first step is that it has to be a multiplication problem, which we're going to have to factor to get it into multiplication. The second step would be then to cancel the terms that are the same. So any term on the top with the term on the bottom is going to cancel. And it has to be on the top versus the bottom. And they must be identical. The whole term must be the same, the whole quantity. So looking at the first 3 problems here, we have x squared plus 7x plus 10 divided by x squared minus 4. This is just simplifying. So we don't have 2 fractions that we're multiplying together. This is just one fraction. Even though the fraction has a couple of pieces on the top and a couple of parts on the bottom, it's still considered one fraction. So in order to simplify, you have to factor. Because this is not multiplication. And the property we just talked about said it must be multiplication in order for us to cancel. So you cannot be like, oh wow, I have x squared, I'm just going to eliminate them because they're both x squared. It's not a multiplication problem. It's addition and subtraction. And pieces cannot eliminate unless it's in multiplication form. So we're going to factor it to make it into multiplication. Garrett, how could we factor the numerator, x squared plus 7x plus 10? Yeah, so we have a 10 here. Garrett, what 2 numbers multiply to get 10? 5 and 2. And because there's just a 1 in front here, Garrett, how would that factor then?
X plus 5 and then x plus 4.
Perfect. X plus 5, x plus 2. So that's like that shortcut factoring. We don't have to do the whole grouping part because it's a coefficient of a 1. And then looking at the bottom, so now the top is multiplication. I have one set of parentheses times another set of parentheses. That makes it multiplication. Garrett, what would you do with the bottom, the x squared minus 4?
It's the same thing.
So that would look like,
X plus 2, X minus
yeah. So that's a perfect square. We call that the difference of perfect squares. So one is a plus, the other one is a minus. The plus and the minus are there because that's how you get that middle term to cancel. So once it's multiplication, any term that's the same on the top can cancel with the bottom. So Abby, what could we cancel out of the problem? Yeah, the x plus 2's. And we're left with x plus 5 divided by x minus 2. Can anything else cancel from that problem? Are you still multiplying? No. So this x here is connected with the plus 5. They are glued together with that plus sign. The x minus 2 is a totally different piece of the problem. They're not the same. They cannot cancel because it's not multiplication. So x plus 5 divided by x minus 2 is as far as you can simplify. Even though you're thinking to yourself, but those x's are the same, they're not. This x is with a plus 5. The other x is with a minus 2. They are different quantities. The quantity isn't the same. You cannot cancel it. Questions? All right, so looking at letter B, this one is the GCF type of factoring. So we still need to factor first. That's always going to be the first step. Got to break it down so that it looks like multiplication. Odette, what would you do to factor the numerator?
I took out 4xy.
So they're both divisible by 4. They also have an x and a y. And what's left in the parentheses then?
2x plus 3y.
Okay, so numerator is now changed to multiplication. Something in front times a quantity in parentheses. Odette, how about the denominator? What can we take out of there?
6x squared.
So both divisible by 6, 12 and 18. And then the x squared, they both have an x squared because we have an x squared and an x cubed, and then they both contain a y. And Odette, inside the parentheses is also 2x plus 3y. So first step is to factor, break it down. And then when you look to see what you have left, if there's a quantity that is exactly the same, then you can cancel it. And look here, we've got that 2x plus 3y. 2x plus 3y. So now we have 4xy divided by 6xy squared. Can that be simplified any further, Odette?
You can make it 2 over 3.
Why?
It's still multiplication.
Exactly. So the difference between this problem and that problem. Here we have addition and subtraction. In this one, it's still all multiplication. And as long as it's multiplication, you're allowed to simplify because that's one term on the top divided by another term on the bottom. All those pieces are still being multiplied together. So our x's can cancel. The y on the top cancels with the 1 on the bottom. Because I have 2 on the bottom, I'm getting rid of the 1 on the top. And then you said,
The x is the one squared.
oh, thanks.
So it would be 2 over 3x.
So the y's cancel. And she said 2 on the top, and then a 3 and an x on the bottom. Thanks, Annette. But you're allowed to cancel in that problem because it's still multiplication. So addition, subtraction, not allowed to cancel. Once it's out of multiplication form, there's no extra canceling. Questions? So looking at number 3, again, we have a problem here that needs to be factored first. So looking at that AC, this is the shortcut AC again for both of these. We're looking at a 4 on the bottom and negative 5 on the top. So will two numbers that multiply to be negative 5 combine to be negative 4? right the first time. So negative 5 plus 1, because we want a negative 4. And then we'll, on the bottom, we have a 4, but we want a positive 5. So 4 and 1. X plus 4 and x plus 1. So factored form can be canceled because you're multiplying. We have an x minus 5 and an x plus 4. Questions? So that is just simplifying. You're simplifying one fraction, one rational expression. The other thing we're going to talk about today would be multiplying and dividing multiple fractions. So now we've got a couple of fractions that we're looking at. It says let A, B, C, and D be non-zero real numbers or variable expressions. The rule for multiplying rational expressions is the same as the rule for multiplying numerical fractions. So when you're multiplying 1/2 times 3/4, something like that. So we want to multiply the numerator. Both numerators get multiplied together. And then we multiply the denominators. So essentially, you're multiplying the top together, you're multiplying the bottom together. The same parts of the fraction get multiplied together. And then it says write the new fraction in simplified form. So if I multiply across, I get AC times BD. Whatever's on the top times whatever's on the bottom. And then it says simplify if possible. So if we can simplify it, then we want to make sure we do that. These steps are written out for you. The first step says factor. You're going to hear me say that many times. Factor first. That's the first thing you should do with any of these problems. Factor it. If it can be factored, factor the problem. Divide out any common factors to simplify, and then multiply the remaining terms together. So actually, we multiply last. We're going to simplify it as far as it can be simplified first, and whatever is left in the problem, then we'll multiply. So that'll be the last thing that we look at. So we have 20x minus 5x squared over x squared minus x. And then you're multiplying that with another fraction, x squared plus 3x minus 4 over x squared minus 16. Connor, what can we do with that left numerator?
Well, you can take out a 5x.
And if you take out a 5x, what do you have then?
4 minus x.
Yeah. So take out a 5x, and then he said we would have a 4 minus x. Connor, how about the denominator there on that fraction?
Take out an x.
Take out an x, and you would have left
X minus 1.
x minus 1. So factor first. We factored the left side of the problem, the left fraction. So looking at the right fraction, Emma, how could we factor the numerator of the right? Yeah, so she said 4 and negative 1. And then Emma, how about the denominator? So the denominator, that's that perfect square. So difference of perfect squares must be subtraction. If it's subtraction and it's a perfect square, you can factor it with the plus and the minus. So factor first. Then the next step said to divide out common factors and simplify. What can we divide out? Julia?
In the first one, you can take out the x on that side.
Yeah, so the first one, we have the x's that were pulled out. They're being multiplied because it's x times the parentheses, so we can cancel those. Julia, what else could we
And
cancel?
then another one, you can take out the x plus 4.
Yeah, and the other one, we can take out the x plus 4 because it's the same. So if we look to see what we have left, we have a 5. We have this 4 minus x over x minus 1. Over here, we have an x minus 1 and an x minus 4. be,
X minus 1.
yeah, the x minus 1. It's okay that they're not in the same fraction. When you're multiplying, anything on the top multiplies with anything on the bottom, and you're allowed to cross cancel. So if I would have 1/2 times 4/3, in 4th and 5th grade when you learned this, you would cross cancel. You would reduce it before you actually did the multiplication to make the multiplication easier. So I would say 4 and 2, the 2 goes into 4 2 times, and then I'm left with 2/3 because it simplifies. So we can do the same thing with rational expressions. You're allowed to cross cancel as long as it's on the top of one and the bottom of another fraction. They can't both be on the top because that's what's getting multiplied, but the top of one and the bottom of the other. There's actually one other thing that we could do with this problem to simplify it. Connor?
Cancel 4 minus x times 4.
How can you cancel them? You have to do something first to cancel them. Ellie?
Make the 5 negative.
Yeah, so if you look at this 5 right here, the 5 up here, that was 20x minus 5x squared. If we take out a negative 5 instead of a positive 5, so up in my original problem, if we take out a negative 5, that makes this a positive x and this a negative 4. So 20 divided by negative 5 is negative 4. Negative 5 divided by negative 5 leaves us with a positive x. So when you see that two terms are exact opposites of each other, we had an x minus 4 and a 4 minus x, there's a negative that can be factored out of the problem. Nice job, Ellie. So Ellie, your only thing left here would be a negative 5. That's the only thing remaining in the problem. Negative 5. Questions? So there's a lot of canceling. That's usually what happens with these problems. You're going to have a whole bunch of things canceling out. So see if you can factor the one on the right. Each piece needs to be factored except for that one little denominator there. That 2x cannot be factored. Mackenzie Myers, how do you factor the top left?
You can take out 2x and then x plus 2.
And then the bottom?
Make it factored into negative 6.
Good. So she said negative 6, positive 2. So that looks like
X minus 6 and x plus 2.
excellent. And then the top up here, we have an 18. Kushal, what's your numbers multiplied to be 18 but combined to be negative 9? 6 and 3, so how would that factor?
X minus 6, x minus 3.
So factor first, then cancel. Maddie, what do you see that's in common that we can cancel?
2x.
So 2x, again, it's all right if they're diagonal from each other. You're cross canceling. What else, Maddie?
X minus 6.
The x minus 6 and the x plus 2. So then when you look to see what you have left, just kind of look across your fractions. Looking across here, we have an x minus 3. Looking across the bottom, we get nothing. So it's just x minus 3. Questions so far? So we are going to skip the independent practice problems. And we're going to look down to where it says example 3. And it says to multiply a rational expression by a polynomial. So essentially, we're taking something that's a fraction, and instead of multiplying it by another fraction, we're just multiplying it by a polynomial. But we can always make a polynomial into a fraction by placing it over 1. So now it looks like I still have a fraction times a fraction. This one's a special problem. Why is this one special? With that?
It has the x cubed.
Yeah, it has the x cubed in it. That x cubed plus 1. You might want to remind yourself of that pattern. This is that SOAP pattern. So when you factor it, we have a same sign b, a squared, a times b, b squared. And the SOAP, same sign, opposite sign, always a plus sign. That's what SOAP means, the symbols that go in between. So Maggie, can you factor the top x minus 4? No, so that doesn't factor, it just stays as x minus 4. How about the bottom, Maggie? So how would that factor? What's the a term, what's the b term?
The a term is x plus or x.
And the b is just 1. So then how would it factor?
X plus
Mm-hmm.
and then x squared minus 1x plus 1 squared.
Good, perfect. So a same sign b, a squared, opposite sign, a times b, always positive, b squared. And we're multiplying that with x squared minus x plus 1. So Melanie, what's the magic with this problem? After you factor it, what do you notice?
They're the same.
Yeah, they're the same. So after you factor using SOAP, these two quantities are the same. The polynomial that we were given is the exact same factor after you use SOAP. So they cancel. If they're the same, that whole quantity cancels out. So looking to see what we have left, there's an x minus 4 and then the x plus 1. Can that be simplified any further? No. It's now addition. The multiplication is gone. Once it becomes addition, you're done simplifying. And we have a subtraction on the top. So no more simplifying in that case. So looking at letter B, same type of problem. Just going over the SOAP method again. Got an x minus 4. So Julian, how would you factor the left denominator with SOAP?
It would be x plus 2 times x squared minus 2x plus 1.
And then your final answer is?
X minus 4.
Nice job. Again, don't get cancel happy. Like, yeah, I know we have a 4 and a 2 there. They cannot reduce, they cannot simplify. They're glued together with subtraction versus addition. Any questions with multiplication and simplifying? So there's one other thing that we're looking at today. So we did basic simplifying with one fraction. We did simplifying when you have multiplying two fractions together or multiplying a rational expression and a polynomial. And the last thing we have to talk about, of course, is division. So we can't leave out division because that would be our other type of operation before we get to addition and subtraction that we can do. To divide one rational expression by the other, multiply the first expression, that means the first fraction, by the reciprocal of the second. So we need to multiply the first expression by the reciprocal of the second. And you can see here that we have a divided by b, a over b, divided by c over d, The first fraction stays the same, but the second one is the one you take the reciprocal of. So we're flipping that second one because division is really multiplying by the reciprocal. They're inverses of each other. So in order to do division, we actually multiply by the reciprocal of the first. And then you're multiplying whatever you have left, so A times D, B times C. So still going across. And of course it says simplify if possible. So the first thing that you need to do is take the reciprocal of the term or the fraction after the division sign. Not the one before. It's whatever follows the division. Because the first part, you're dividing by the second, and that second part is the one that flips. And then you will factor and simplify. And then finally, we're actually multiplying. So we take the reciprocal of the term after the division sign. You factor, you simplify, and then finally you do multiplication. So divide the following rational expressions. The 3 over x plus 7 stays the same. Here's my division sign. Whatever follows the division is what you flip. So we're taking the reciprocal of the second fraction and flipping it. So reciprocal means flip. Change it to multiplication and flip at the same time. Factor, simplify, multiply whatever happens to be left. Holly, how would you factor the numerator of the fraction on the right side?
You get x plus 7.
So she said 7 and negative 1. And then Holly, what about the denominator?
You take out 8x and you get x plus 1.
So canceling all of the common quantities, we have an x plus 7, one on the top, one on the bottom, canceling diagonally, the x minus 1. And then looking to see what's left on the top, it's a 3 going across and an 8x. So 3 over 8x. Questions? So letter B, 4r cubed, 9s squared. Here's division. Division really is multiplying by the reciprocal of whatever follows the division sign. So we're flipping, and now 15rs is on the top, 8r squared s to the 4th is on the bottom. And then you need to cancel. So you are allowed to cancel vertically, you're allowed to cancel diagonally, or you could choose to multiply the first, the top, multiply the bottom. It's kind of up to you. But this one doesn't get factored because there's no addition or subtraction sign, so we don't need to factor. So if you prefer to cancel first, cancel away. Or if you'd rather multiply all of the top together and then all of the bottom together, you can do that as well. It's kind of your choice. So whatever you see as you're looking at the problem. This goes back to chapters 5 and 6 when we were working with exponents. We did rational exponents, we did whole number exponents, we did negative exponents. So Connor, how are you thinking about canceling this problem, simplifying it? What do you see?
You could take out the s from 15rs and the s from 9s.
Yeah, so this s here changes, he said the 9s squared, we'll take out 1 there. So the s over here is gone. 9s squared is just 9s. What else could we cancel? Abby, what do you see?
You could take out 2
Okay, so this r squared is gone. And diagonally up on the top, if there were 3 of them, we took 2 out, so now there's just 1. Anything else can cancel? Julia.
With the 15 and the 9, you could take out 3, so 35.
Yeah, so they can reduce. 15 and 9 are both divisible by 3. So the 9 becomes a 3, the 15 becomes a 5. That's just simplifying your numbers, dividing by what they have in common. And then Julia, the other pair of numbers diagonally,
You could take out 4, so it'd be 1 and 2.
and this would be a 2. So I know like what you have left might look a little messy. Try and be neat about it. Might be a little easier to kind of look across. So now you're looking across the fraction. We have a 5 and a 1. So looking at the numbers first, 5 times 1 is just 5. There's an r on the left and r on the right. So we have 2 of them. That makes r squared. R times r is r squared. So just kind of looking to see what do you have on the top. Nothing else is on the top. Everything else is crossed off. On the bottom, getting the numbers 3 times 2 makes 6. Here's 1s, 4 more, so now we have 5. So 5r squared divided by 6s to the 5th. If you missed something after you do the multiplication, just look to make sure whatever you have left doesn't have anything else in common. So 5/6 cannot reduce. An r and an s are different variables. They cannot reduce. Any questions?